In this lecture, I will share some important points about vector quantities. First of all, let us define what is meant by vector quantities. Vector quantities are those which have magnitude as well as direction for their complete explanation. For example, suppose we have a body, we apply some force on it, force of some magnitude. The body will move in accordance with magnitude of force and also in accordance with direction of force. If I apply force in this direction, body will move towards right. If I apply force in vertical direction upward, then the body will move in upward direction. Means force is such a quantity which has both magnitude as well as direction. Such quantities which have both magnitude and direction are called vector quantities. In contrast to it, the quantities which have no direction, they have only magnitude, those are called scalar quantities. For example, there is a quantity known as mass of a body. Mass of a body, we say, suppose it is 10 kilogram. There is no need of saying in which direction mass is this. Only magnitude description is sufficient to express a scalar quantity. So this is the difference between a vector quantity and a scalar quantity. Now the next question is how to represent, how to distinguish a vector quantity from a scalar quantity. Suppose we have a quantity A. If it is scalar, we simply write it A. If it is a vector quantity, then we put an arrow overhead the symbol of that quantity. This is the symbolic representation of a vector quantity. We can call it symbolic representation. Next point I want to share how to represent a vector quantity geometrically. That is called geometrical representation of a vector quantity. For this purpose, let me take an example. Suppose I have a quantity force of 10 Newton in east direction. Direction is also given to us. How to represent it diagrammatically? Let me suppose 1 Newton is equivalent to 1 centimeter. What will I do? I will draw a line of 10 centimeter length 5, 6, 7, 8, 9 and 10. This 10-meter line, 10 centimeter length line represents magnitude of force, that is 10 Newton. And direction is towards east. We know 4 directions are there. This is called east direction, this is called north direction, this is west direction, and this is south direction. According to this, the direction of force is towards this side, so I can put an arrow on this side. So this arrow of length 10 centimeters represents a force of 10 Newton in east direction. This is our choice. We can, if the magnitude of force is very large, then we can change the scale. Then 20 Newton can be taken equal to 1 centimeter. 30 Newton can be taken into 1 centimeter. This is up to our hand. So we have to draw an arrow of length proportional to magnitude of the quantity, and we put an arrow in the direction given. So this is how we can geometrically represent a vector quantity. Next point I want to share is what is meant by a unit vector. It is a special type of vector whose magnitude is 1 and it is denoted as A with a cap overhead. Now the question is, what is the definition of unit vector? Every vector has a unit vector associated with it, and we can express a unit vector as complete vector equal to magnitude of vector multiplied with its unit vector. Or I can write a cap is equal to a vector divided by a. Both these relations are same. Sometimes we write this relation a vector is equal to magnitude of a multiplied with unit vector. Sometimes we write unit vector is equal to vector divided by its magnitude. So this is the definition of a unit vector. For example, as I explained earlier, suppose we have a vector that is force vector in this direction. It is of 10 Newton 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose I have expressed it with a line of 10 centimeter. So each part of this may be called as a unit vector because each part represents 1 Newton of force if force is of 10 Newton, and the direction of this small vector is same as that of the main vector. So this vector is nothing but a cap, that is a unit vector of force F vector. Next point I want to share what is meant by a position vector. Position vector means it is a vector that represents the position of a body, the location of a body. Suppose we have a coordinate system consisting of x-axis, y-axis, z-axis, which are mutually perpendicular, meeting at origin. Suppose there is a point P in the space, we want to find its unit vector. What will we do? We join origin to the point of observation. This vector starting from origin and terminating at the point is nothing but position vector of point P. So position vector is OP vector. In general, we represent position vector as small r vector. So we can write OP vector or r vector. This is the definition of position vector. So I can say position vector of a point is the vector joining the origin to the point of observation. This is called a position vector. Next point is very useful in physics regarding vectors, that is what is meant by components of a vector. As the name implies, suppose we have a vector r. If I can write equal to a vector plus b vector plus c vector plus d vector and so on, then all these vectors on the right hand side, the sum of which is equal to the given vector, then these vectors are called components of a vector. So a vector, b vector, c vector, so on are the components of r vector. This is the meaning of components of a vector. And this vector is called resultant of these vectors. We can talk both ways. Now, next point is some components are called rectangular components. rectangular components. These are those components which are perpendicular to each other. All these vectors may or may not be perpendicular, but if the vectors into which a given vector can be splitted, if they are perpendicular to each other, then these are called rectangular components. Maximum number of rectangular components of a vector can be 3. Let me take an example that there is a given vector A. Suppose I can split it into 3 vectors. One is a x vector, second is a y vector, and the third is a z vector. Not more than 3. What is the meaning of these 3 vectors? Ax vector means component along x-axis. Let me draw Cartesian coordinate system. We have x-axis here, y-axis, z-axis, origin. Suppose there is any vector A. If its component one is along x-axis, component along y-axis is a y vector, component along z-axis is a z vector. So these 3 vectors into which a given vector can be splitted, which are mutually perpendicular, are called rectangular components. Now I can write each of these 3 vectors as ax into I cap plus ay into j cap plus az into k cap. What I have done, I have used the definition of unit vectors. What is I cap? It is a special unit vector along x-axis. Unit vector along y-axis is denoted by j cap, and unit vector along z-axis is denoted by k cap. So ax is magnitude of ax vector into its unit vector I cap. As I have earlier told, any vector is equal to its magnitude multiplied by its unit vector. I have used this definition in writing the values of all these 3 components, ay into j cap plus az into k cap. Next point is how to find component of a vector in any direction. Component in any direction. What is the formula for that? So this is calculated by using the formula. You write the magnitude of vector and multiply with cos of the angle between the 2 directions. So what is the meaning of this? Suppose I have a vector A in this direction. We want to find its component in this direction. What will we do? Let's measure this angle theta and put magnitude of this vector, multiply with cos of the angle. It will give component of the vector in this particular direction. So this is nothing but component of a vector along this direction. That's all.